Let's go. Alright, so question, what do you mean question from? This is question 9E, yeah, exercise 9E. Alright, cool then. No problem, yeah. Question 1A. It's pattern 1A. 1A is saying to differentiate this, yeah, so we've got y is equal to 5x over x plus 1, yeah? So here we need to use the quotient rule, yeah? Because you've got a function on top of a function, yeah? So in the compound rule, or whatever the fuck's called product rule, yeah? You do function divided, times a function, yeah? Here's a function divided by a function, yeah? So therefore the function u is going to be 5x, and the function v is going to be x plus 1, yeah? So u is the top one, v is the bottom thing, yeah? Alright, calm. So now you're going to do du over dx, yeah? So that's going to be 5, and then dv over dx, which is going to be 1, yeah? Alright, no problem. So that's 1 there, 5 there, yeah? Now, you need to use the product, the quotient rule here, yeah, which is dy over dx is equal to v. So in product rule, we do u. Remember, we do this times this plus this times this, yeah. Here, we're going to do v first, yeah, v times du, yeah, and order is important here, yeah. So you need to do v times du, and then this times this, yeah, and take them away. So v times du over dx, yeah, minus u times dv over dx, and then all of that over v squared, yeah. You can already see how this can get long, yeah? Alright, calm. So let's do that then, obviously. We've got v times du, yeah? V times du is just going to be x plus 5, 1 times 5, yeah? So 5x plus 1 minus, take away u times dv. So u is 5x, 5x times 1 is 5x versus 5x over v squared, yeah? So x plus 1 squared, yeah? And obviously simplify this. 5 times x is 5x, 5 times plus 1 is 5, 5x minus 5x is 9, so it's just 1 over x plus 1 squared, yeah? Alright, calm. Alright, cool. Alright, question B, yeah? Y is equal to 2x over 3x minus 2, yeah? So u is equal to the top hand side, that's 2x here. V is equal to the bottom hand side, that's 5x minus 2. So therefore du is going to be what, bro? Du over dx is going to be 2, yeah? And dv over dx is going to be 3. Alright. Now, obviously, we need to do the same thing. So, again, I'm not going to write out the formula, but I'm just going to do it so you can get used to doing it without the formula, yeah? So, v times that first, so 2, open bracket, 3x minus 2, yeah? Take away that times that, so that's 6x, over v squared, yeah? So, v squared is 3x minus 2 squared, yeah? So, 3x minus 2 squared, yeah? Alright, save. Span the top here, so 2 times 3 is 6x, 6x minus 6x is going to be nothing, yeah? And then 2 times minus 2 is minus 4, so it's minus 4 over 3x minus 2 squared, yeah? Alright, come on. Question C, yeah? Y is equal to x plus 3 over 2x plus 1. So u is equal to x plus 3. V is equal to 2x plus 1. Find du over dx here is equal to 1. Find dv over dx is equal to 2, yeah? Alright, come. And now what you want to do, yeah, is obviously, again, u times dv, yeah? So that's going to be 2 open bracket x plus 3. No. See that? See that? I'm too used to the compound rule, yeah? That man's doing that now, yeah? V times du, obviously, yes? We got 2x plus 1 times 1, which is 2x plus 1, yeah? Then take away, and then 2 times that, yeah? So 2 times x plus 3, yeah? It's because I had the previous one, yeah? And it was compound rule, innit? And 2x plus 1 squared, yeah? So 2x plus 1 squared, yeah? Alright, save. So now, obviously, 2x minus 2x is going to be nothing, yeah? 1 minus 2 times 3 is going to be minus 5, yeah? Reasoning for that is because minus 2 times 3 is minus 6 plus 1, that's minus 5, yeah? Over 2x plus 1 power of 2, yeah? But don't even ask my reasoning for that. Just take it as it is, bro, because you know that is correct, you know what I'm saying, yeah? So there's no need to even ask the reasoning, you feel what I'm saying? Alright, question D, yeah? Y is equal to 3x squared, yeah? Over 2x minus 1, yeah? Squared, alright, calm. So u is equal to the top hand side, that's 3x squared. V is equal to 2x minus 1 squared, yeah? And now you want to differentiate both situations here. So differentiate both situations, you want to do du over dx here. So you're going to want to bring that 2 down here. That's going to make 6x. And then take away 1 from the power, so it's just 1. You don't need to write anything. And then dv over dx here is going to be, take the 2 down, yeah? So 2 is there, 2x minus 1, yeah? And obviously take away 1 from the power. And obviously also differentiate the inside as well, which is going to be 2 times the 2 outside, which is going to be 4, yeah? So that's going to be 4, open bracket, all of that. Calm, using the chain rule, yeah? No problem, yeah? So now what you want to do, again, times v times my man, that's going to be 6x, open bracket, 2x minus 1, the power of 2, minus take away, then that times that, yeah, that's going to be 4 times 3 is 12, so that's 12x squared, 2x minus 1, yeah. Alright, save all of that over 2x minus 1, yeah, squared. But it's already squared, so we need to square that again. That's going to come to power 4, yeah. Alright, expand the top here. You need to do another one of these situations, you know, where you take out 2x. So if you don't know about this, look at the previous one, yeah, and you'll see it a lot, yeah. So you need to take out 2x minus 1 because it's in common, and you also need to take out 6x because it's in common as well. So 6x, take that out, yeah, and take out 2x minus 1, yeah. And so divide 6x, 2x minus 1 squared by that, you're going to get left with just 2x minus 1. And then here, you already took out 2x minus 1, you already took out x squared, yeah, so you're getting left with minus 2x. Over 2x minus 1 to the power 4, yeah. And now obviously tidy that up here, so that's just going to be what, bro? 2x minus 2x is 0, so it's just minus 1 times all of that. So you can just write as minus 6x open bracket 2x minus 1 over 2x minus 1 to power 4, yeah? Alright, calm. So also again, yeah, 2x minus 1 cancels the 2x minus 1 to power 4, so that's going to be minus 6x over 2x minus 1 to power 3, yeah? Alright, calm. Question E, yeah? Y is going to be equal to 6x over 5x plus 3 power half, yeah? Use the top here, so use 6x, yeah? No problem. V is going to be the bottom here, so V is going to be 5x plus 3 power of a half here. Alright, safe. So there we're going to do du over dx here. Du over dx is going to be 6 here. dv over dx on the other hand, yeah, is going to be what, bro? Yeah, what's it going to be, yeah? You lot say it into the screen, yeah? I'm just fucking wasting time. Half, bring down the half here, you get 5x plus 3. Take away 1 from half, that's going to be minus half, so that's negative a half here. Alright, so if differentiate the inside, that's going to be 5 times 5 outside, that's going to be 5 over 2. You see that situation there? Yeah? Alright, calm. So it's going to be 5 over 2, yeah? Now, obviously, you want to do this times this, so 6 times that. So 6 open bracket 5x plus 3 to power of a half. Take away this times that, yeah? So we're gonna do 5 over 2 times 6, by the way, is gonna be 15, yeah? So that's 15x open bracket 5x plus 3 minus half, yeah? I ordered that over v squared. V is 5x plus 3. 5x plus 3 to the power of a half squared. You're going to do 2 times a half here, which is going to be 2 over 2, which is 1, yeah? So it's just going to be 5x plus 3 on the bottom here. You get that situation here. Let me write it out here for you quickly. So 5x plus 3 to the power of a half here. We said we're going to square that here. So therefore you times the power inside plus 5x plus 3 power of 2 over 2, which is just 1. So here. Alright, so we've got this situation here. Again, we're going to need to take away the smaller one. You know the process by now, bro. We've got 3 in common between 6 and 15. So take out the 3. And we've got a... shit, you don't even need to do that. No, you do. Yeah, of course you do, bro. You think the book was just gonna let you go off easy? Yeah, of course you do, bro. Yeah, a standard, bro. Alright, so take out 3, yeah? And then 5x plus 3, this is the smaller one because it's minus a half, yeah? So you need to take out 5x to power, 5x plus 3 to power of minus half, yeah? So take out that, and then open bracket here, yeah? And so divide 6 by 3, that's going to be 2. Divide 5x plus 3 to power of a half by 5x plus 3 power of minus half. We talked about this before, yeah? You're going to do minus minus, which is going to be 1. So you're just going to be left with 2 open bracket 5x plus 3, yeah? And then minus 5x here. Because this whole thing, take away 3 is going to be 5x. And then that got taken away anyway, so 5x here. By the way, yeah, if you don't ever get confused there with these things, yeah, the way it's made here is that if you go through every single one, every single video, so if you don't understand this part here, that didn't come through that quickly, then just look at the previous one, previous video, watch the whole thing here, and you'll clock it straight away. You get me? That's how these are made here. Alright, safe. So cool. Tidy up this side here. So 2 times 5 is 5x, 2 times 6 is that, so that's gonna be 3 open bracket 5x plus 3 here to the power of minus half here. And then inside this bracket, 2 times 5 is 5x, is 10x here. 10x minus 5x is 5x. 2 times 3 is 6, so it's going to be plus 6 here. Over 5x plus 3. Alright, safe. So now, this is technically like 5x plus 3 to the power of 1, yeah? So we're going to do half take away 1, yeah? Half take away 1 is going to be minus 3 over 2, yeah? That's negative half take away 1, yeah? That's minus 3 over 2, yeah? And so what you can do now is you can combine that. It's going to become 3, open bracket, 5x plus 3 to the power of minus 3 over 2, 5x plus 6, yeah? And as a final answer, you can write that because it's negative, you can do 1 over. So because you can do 1 over, we can just write this as 3 times 5 over 6, 5x plus 6, over, because negative here, power, 5x plus 3, obviously to power of 3 over 2. Yeah, and that's the answer. Alright, question 2a. Question 2a, we've got e to the power of 4x here over cos x here. Okay, safe. So we've got u is going to be equal to e to the power of 4x, and v is going to be equal to cos x here. So we're going to do du, yeah. Du is going to be du over dx, going to be bring the 4 down here. So that's going to be 4e and then stay up here. So 4e to the power of 4x. And then here, bro, we're going to do differentiate cos x here. Differentiate cos x as dv over dx here. That's just going to get what, bro? That's going to get minus sine x here. We know this by now, yeah? And now what you want to do here, same shit. So just v times that is going to be 4 cos x e to the power of 4x. Ah, fuck that, fuck that. Write e first, write e first. 4 e to the power of 4x here, cos x here. And then negative, so then you're going to take away that times that, yeah. But because it's already negative, it's going to make double negative, which can make positive here. So positive e to the power of 4x here, sine x here. Okay, cool. And all of that is going to be over cos squared here. So all of that over cos squared x. Reason it's cos squared is because we do it over v squared, yeah. And then v is cos, yeah. Alright, come on. That's nearly the end. All you need to do now is you take out e to the power of 4x, yeah. So take out e to the power of 4x, you get 4 cos x plus sine x. And then all of that over cos squared x. Alright, safe. So b now, yeah. So we've got y is equal to ln x here over x plus 1, yeah. So u is going to be equal to ln x. V is going to be equal to x plus 1. And then du, yeah, is going to be equal to 1 over x here because we're differentiating ln, yeah. And dv over dx is going to be equal to 1, yeah. We're differentiating that, yeah. So now what you want to do is obviously times that by that. So we're just going to get ln x here. And then, my bad, I keep doing this, bro. Times this by this here, so that's going to be x plus 1 over x here, and then take away 1 times that, which is going to be 1 times ln here, which is going to be ln x. And all of that is going to be over v here. Alright, safe. So that's going to be that here. And then now, what you want to do is obviously you're going to do what you want to do is you want to split it up, yeah. So basically that over that minus that over that, yeah. So x plus 1, yeah, over x plus 1 squared, yeah, minus ln x over x plus 1 squared, yeah. Alright, cool. No problem, yeah. So now, let me just take it to the side a little bit here. I've got x plus 1 over x here, divided by x plus 1 squared. So divided by x plus 1 squared here, which is technically x plus 1 squared over 1, you can think of it here. So what you do here is you do keep flip change here. So you change this to times, and then you flip the second one here. So that's 1 over x plus 1 squared here. Times x plus 1 on the top here, that's going to be x plus 1 here over x open bracket x plus 1 squared here. Obviously, bro, that cancels with that. So you just get 1 over x open bracket x plus 1 because you've got squared here instead of the way the squared here. I shouldn't cancel that. I should just go with that. And you get that, yeah? So now, what I was trying to prove here is that this thing here simplifies into that, yeah? So we get 1 over x open bracket x plus 1 minus ln x over x plus 1 squared, yeah? Safe. That's the answer, by the way. Alright, cool. See ya. Alright, cool. So y is equal to e to the power of minus 2x here plus e to the power of 2x over ln. Calm. So u is going to be the top hand here. So u is going to be e to the power of minus 2x here plus e to the power of 2x here. And then v is going to be the bottom here. So ln x here. And so now I need to do du and dv here. So du over dx is going to be, just bring the minus 2 down. So that's minus 2 e to the power of minus 2x plus 2 e to the power of 2x here. So I've got that situation there. I'm going to do dv now over dx. That's just going to be 1 over x here. Alright, save. Bro, this, alright, cool. Alright, save. So now, v times that, yeah? So ln x, open bracket, I'm going to write 2 e to the power of 2x and then minus 2 e to the power of minus 2x, yeah? Just for like, like writing it properly, yeah? And we're going to do take away this times this here. So that's going to be e to the power of minus 2x plus e to the power of 2x over x here. Alright, save. Got that situation there, yeah? All of that is obviously over v squared here, which is ln squared, yeah? So ln, all of that is over ln x here squared. Okay, nice. Come. Now, what I can do here is to clear this fraction here, I can times everything by x. So times this by x, I times this by x is going to clear this fraction here. And I'm going to times x as well over here. So it's going to become that there. Alright, so we cleared the fraction now. And now what you want to do is, well, it's up to you basically. What you want to do now is you want to basically take out the 2 here. So you see how there's a 2 there, take that out, put that there. So now it just becomes e squared minus whatever. Yeah, nice and simplified. And now, as you clock, you can clock straight away. Bro, this really is not a like nice looking question. Like, look at the answer. The answer would just be taking e to the power of 2 minus 2x out of this here. So take out e to the power of minus 2x out of this here. You just get e to the power of minus 2x here, open bracket. Take it out. I know you can barely see it, but it is what it is. Alright, come. So take it out of here, yeah. So you're gonna take it out of here. It's just gonna become ln basically. It's just gonna leave you with 2x. Write ln afterwards, yeah. Take it out. E to the power of 2 minus 2x out of here. That's gonna be 2 minus 2 is 4, yeah. So that's gonna leave you with 4 e to the power of 4x here, and then minus, yeah, 1, because e to the power of minus 2x divided by e to the power of 2x is 1, yeah. So there's 1 there, and then obviously the ln x from there, and then take away the same shit. So e to the power of minus 1, all of that over x ln x squared, yeah. So there's a bit of a shit answer at the end, not really nice form or anything, but that's the answer there. I can't move on to the next whiteboard. You get me? Alright, D. So y is equal to ex here plus 3 power of 3 here over cos x here. Alright, save. So now what do we do here? So now obviously same situation. U is going to be equal to e to the power of x plus 3 cubed here. And v is going to be equal to cos x. So now what you want to do is you just want to differentiate both of them here. So differentiate u, we're going to do du over dx. That's obviously going to be, bring the 3 down, ex plus 3, and then bring 1 from the power, that's 2. Obviously differentiate the inside. The inside differentiate is going to be e to the power of x. So times the outside, so we get that there. Okay, calm. dv over dx here is going to be cos differentiated is minus sine, yeah? So it's going to be minus sine x here. Alright, cool. Alright, cool. So do the same shit. So with that times that, yeah? So we got 3 ex here, open bracket ex plus 3 here, squared here, cos x. Take away, not even take away because it's going to be negative here times that. So that's going to be double negative is positive here. So positive sine x here, open bracket ex plus 3 cubed, bro. Okay, nice. Nice one, bro. Nice one. All of that over v squared. So that's cos x squared here. or cos squared x, doesn't matter. Yeah? Calm. Now we've got ex plus 3 and ex plus 3. So take out ex plus 3. Yeah? So in order to take out ex plus 3, I'm going to take it out now here. So ex plus 3 squared. Yeah? Take that out from here. So we're going to be left with 3ex cos here. And take it out of here, we're going to be left with plus sine. Take it out of here, so we're going to be left with ex plus 3 sine x here. That, yeah, alright, cool, whatever. Yeah, come. Yeah, yeah, come. Over cos squared x here. So the reason I got this here is I just took it out of this, so you just left with 3ex cos x. And took it out of here, so you just left with sine x. And you were left with one of these because it was 3, you took out 2, yeah. Alright, calm. This is it. Just at the end of the question, yeah, calm. Alright, question E. Alright, cool. So y is equal to sine squared x here over ln x here. So therefore you're just gonna do u and v here. U is equal to sine squared x here. V is equal to ln x here. And then du, yeah, I'm gonna differentiate that. If you man don't know how to differentiate this, what you can do is you can make this basically a chain rule situation. So sine x here, you can write sine squared x as this, yeah. So now you've got a function inside of a function, so just bring down the 2. So differentiate the outside, so bring down the 2 like that. And then take away 1 from the power, and then differentiate the inside. The sine differentiates the cos, yeah. So it's going to be 2 times sine times cos, yeah. So 2 sine cos, okay. Calm. So that's going to be 2 sine x cos x. Save. And v, yeah, is going to be dv over dx here. That's just going to get you 1 over x here. Save. Okay, no problem, yeah. So v times that, so ln times that, yeah. Man, it's just like, bro, you get me. Listen, any of you man doing A levels here this year, it will be over soon, but don't worry, man. Times that by that, yeah, sine squared, yeah, sine squared x, save. All of that over v squared, yeah, so all of that over ln x squared, yeah. And then obviously uni, bro, after that, but listen, man, you get trained at that point, bro. Uni becomes chill, it's fine. Split this up. So split that up into, whenever you get stuck like this, more time you probably have to split something up here. So ln x 2 sine x cos x over ln squared, and you can tell straight away that ln x squared is going to cancel there and there, and then take away 1 over x divided by sine squared over that is just going to be sine squared here, x, and you can move this x down here, bro. Okay, so that's going to become x ln x squared here. Just take my word for it, okay? You can do it as well by just doing 1 over x. You just do sine squared over x divided by ln x here, and you'll see what I mean. Yeah, keep flip change. You keep this thing, you'll flip the second one, you'll times it, so it'll be 1 over ln times that. It's going to be ln on the bottom, yeah? You get it. Alright, come. So that's the final answer. Let me just write it properly without this like bullshit on the left hand side. So that cos x over ln x here. Take away sine squared x over x ln x here. Listen, bro. Alright, come. Question 3, yeah? Listen, if you feel stuck on that, yeah, just, bro, remember, yeah, this shit is easy, bro. Yeah, you'll get to a certain level, and you'll find it easy, man. You get me? Yeah, there's people in America probably doing this back in the days. You get what I'm saying? Like, this shit normal. You know what I'm saying? So u is equal to x here. V is equal to the bottom half here, which is x plus 1. Du over dx here is equal to 1 because you differentiate x here. And then differentiate this side as well. We're going to do dv over dx. So differentiate for x plus 1, that's going to be 3. Alright, cool. The times v by du, yeah, if you times v by du, we're gonna get like a specific situation, which is gonna be basically 3x plus 1 pretty much, yeah. I don't know why I waffled like that, but you know how it is here. You know how it is over here already. We waffle bears. 3 times x is 3x, and then over v squared, yeah. So times v squared, yeah. So 3x plus 1 squared, yeah. Alright, calm. And obviously, yeah, 3x minus 3x is just nothing, yeah. So just 1 over 3x plus 1 squared in the end, yeah. Alright, calm. Now you need to find the gradient at that point. So it says x equal to 1 at that point. So we just got 1 over 3 times 1 is 3, 3 plus 1 is 4, 4 squared is going to be 16, bro. So that's a gradient. So dy over dx is equal to that. Alright, save. Question 4. Okay, y is equal to x plus 3 over 2x plus 1, half, half, yeah. Alright. So u is going to be equal to x plus 3 on the top. V is going to be equal to 2x plus 1 on the bottom, yeah, half, half. Du is going to be 1, because that differentiated is 1. dv over dx is going to be that differentiated, which is just going to be bring the half down, yeah. So if I bring the half down, yeah, that's just gonna get half, bro. Let's just skip that. Let's just go full throttle, yeah. Bring the half down, but I'm gonna need to differentiate this inside, then times outside. So that's 2 times half, which is just nothing. So it's just 2x plus 1, and then take away 1 from the power, that's minus half, yeah. You see that, bro, yeah? No need for those little steps, whatever. Nah, fam, we're above that now, yeah. We can do these things, yeah. V times that over there, so that's just gonna be 2x plus 1 to power of a half, yeah, because obviously times in 1 does nothing. And then x plus 3 is over here, so that's x plus 3 and an open bracket 2x plus 1 to half minus a half here. Alright, save. And all of that is over, yeah, v squared. V has a half. So half squared is going to cancel, it's going to be 1, yeah? So that's going to be 2x plus 1 on the bottom, yeah? So the 2x plus 1 half squared, yeah? You get it? Alright, save. Now, obviously, it's going to want you to do a little bit of the factorization situations. No, it doesn't actually. It doesn't need it because it just tells us to find the gradient at x equals 12, yeah? So normally what you have to do is take out half x plus 2x plus 1 to the power minus half, but it doesn't matter, bro, yeah? So x equal to 12, yeah? So therefore, 2 times 12 is 24 plus 1, 25, yeah? So easy. 25 to the power of a half, yeah, minus 15 because 12 plus 3 is 15. And then here it's got 25 again to the power of minus a half. All of that over 25, yeah? So if you put that in a calculator, you're going to get 2 over 25, allegedly, yeah? Alright, cool. Question 5. Y is equal to e to the power of 2x plus 3, yeah, over x, yeah? Alright, safe. So obviously u is going to be equal to the top here, so u is going to be equal to e to the power of 2x plus 3, and v is going to be equal to x. So now you want to differentiate both of them, yeah? So differentiate du, yeah? So du over dx is going to be what, bro? Differentiate the inside, that's 2x plus 3, yeah, that's just going to be 2. So times the outside, so that's 2e to the power of 2x plus 3. If you differentiate the outside, it just remains the same with e, yeah? Alright, calm. And then dv here is going to be what, bro? dv is going to be 1, yeah? So we're going to get 1 there. Alright, save. So we want to do 1 times that, yeah? So 1 times that is just going to be, yo, we're making the same mistake again, bro. V times that, yeah? So V times that is going to be 2x, open bracket e, 2x plus 1. I don't know why I said open bracket for e, but you get what I'm saying, yeah? Minus 1 times that, so that's just e to the power of 2x plus 3. All of that is over x squared, because V squared is x squared. Alright, cool. And now equals, yeah? Take e to the power of 2x outside here, so e to the power of 2x plus 3, open bracket 2x minus 1, and then all of that's over x squared, yeah? Alright, cool. Now, it wants you to find the straight stationary point or some shit, yeah? So we need to make the differentiation equal to 0. This is dy over dx, yeah? So we need to make it equal to 0. So again, when you make something equal to 0, yeah, you're just concerned with the bracket, yeah? So the bracket, you need to find the opposite of that bracket. So the bracket is 2x minus 1. Bring 1 to the other side, divide by 2. So x must equal 1 over 2, yeah? If I put 1 over 2 into here, it will make 0, yeah? Alright, save. So x equal to 0.5 or 1 over 2. And so you need to find what y is to find the stationary point. So substitute that into y, which was given to us in the original equation. So that's 2 times 0.5 plus 3 over 0.5. So the original one was e to the power of 2x plus 3 over x. And that's going to give you 2 e to the power of 4, yeah? So the stationary point here is 0.5, which is the same as half, and 2 e to the power of 4, yeah? Save. And question 6. So y is equal to e to the power of half x, yeah? Over x. So u is going to be equal to the top here. So u is going to be equal to e to the power of half x here. And v is going to be equal to x. Alright, cool. So du here is going to be differentiate that. So bring the half down here. And then here it remains the same. Alright, cool. And now dv here is going to be the same situation basically, but just differentiate x, so 1, yeah? Alright, cool. So now do v times my man, so that's v, so that's going to be half x e to the power of half x. Take away 1 times that is just going to be e to the power of half x here. And all of that is over v squared, which is just x squared, yeah? So all of that over x squared, yeah? Alright, save. Take out e. You see, sometimes here, alright, let me double check the question. See, sometimes I write shit and I just forget it. Let me double check here that this question says e to the power of half x. 1/3. Alright, bro. So all of that shit was pointless. 3 there, 3 there, 3 there, 3 there, 3 there, and 3 here. Okay, so take out e to the power of 1/3. Back on track now, doesn't matter. Little slip up there. It should have been a 3 instead of 2, yeah? Alright, calm. So we're left with x over 3 minus 1, yeah? Over x squared, yeah? Alright. These things happen, bro. You get what I'm saying? It's minor, yeah? So x equal to 3 in this situation. And if you put 3 into here, 3 over 3 is going to be 3. It's going to be 1. 1 minus 1 is 0, so it's going to be 0 times all of this. So it's just going to make 0 as dy over dx here. So gradient is 0. So if they want the tangent or whatever, you can use the same gradient. So y is equal to 0x plus c. That's a gradient. So y is just equal to c. And yeah, since y in the question they gave us was 1/3e, that means that y, the equation is just going to be 1. Y equals 1/3e. That's the answer. Question 7, yeah. Y is equal to ln x here over sine 3x. Use the top here, so use ln x. V is going to be sine x, sine 3x. du over dx here is going to be 1 over x. dv over dx is going to be, bring the 3 outside and then change it to cos, so 3 cos 3x. Okay, nice. And then sine times that is going to be sine 3x over x. Take away that times that is going to be 3 ln x cos 3x. All of that over v squared, which is sine 3x. So that's going to become sine squared 3x. Obviously, you already know what to do when you have like an over x situation here. You just need to times everything by x here. So times x here, times x there. And then this goes away. And now what you need to do is, well, nothing, because that's it. Now what you need to do is write x equals to pi over 9, because it wants to gradient at pi over 9. So therefore, put pi over 9 into here. So that's going to be, let me use new whiteboard for that. So it's going to be sine, so dy over dx is going to be sine 3 times pi over 9, yeah? Minus 3 open bracket pi over 9. ln pi over 9 times cos 3 times pi over 9. Okay, over pi over 9 sine squared 3 times pi over 9. Okay, calm. So let's simplify this. If we simplify this situation, sine 3 times pi over 9 is just going to become root 3 over 2. And then minus, it stays the same. And then this whole thing simplified, if we do 3 times pi over 9 times cos 3 times pi over 9, we'll get minus pi over 6 here for all of that. And then just ln pi over 9. And then the bottom side is just going to be 3 pi over 36. Alright. 3 pi over 36 here. Alright, safe. Calm. Now, yeah, obviously what we need to do here is times everything by 6 here. Not even 6 times everything by 36 here to clear shit. So you're gonna get 18 root 3 up here. You're gonna get minus 6 pi ln pi over 9. So that's timesing it by 36. And then times 1 by 36, you get 3 pi. That's why we did it here to clear it. And now just divide by 3 in it. So this divided by 3 pi, that divided by 3 will get you 6 root 3. And then 6 divided by 3 is 2, so minus 2 pi ln pi over 9. And all of that over pi. Alright, cool. That's it. That's the answer. Alright, cool. Question 8, yeah? Got x is equal to e to the power of y over 3 plus 2y, yeah? Let me read the actual question. Find the coordinates of the point P where cos of x-axis, yeah? So cos of x-axis, that means that y is 0. So make y equal to 0. So that's just going to be e to the power of 0 over 3, because 2 times 0 is 0. That's going to be 1 over 3, because e to the power of 0 is 1. So therefore, the coordinate is going to be 1 over 3 and 0, yeah? Alright, safe. Part B, yeah? So we need to differentiate it. So on the top we had e to the power of y, so use ey. On the bottom we had 3 plus 2y, so v is 3 plus 2y, yeah? And now we're going to do du over dy because we're differentiating into respect of y, yeah, not x here. So it's just the same thing, ey. And then dv over dy is going to be 2, yeah? Alright, so same thing here. So times v times that, that's going to be e to the power of y, open bracket, 3 plus 2y. And then take away 2 times e to the power of y, yeah? Then all of that over v squared here, which is over 3 plus 2y squared here. Alright, now e to y times 3, that's 3ey, and 2y times e, yeah, so what I was trying to say here is that 3 times ey is going to be 3ey, yeah, that's going to be 2y ey, and that's going to be minus 2ey, yeah, so all of that's over 3 plus 2y squared, yeah, and obviously, bro, 3 minus 2 is 1, so that's just going to be 2y ey plus ey over 3 plus 2y squared, yeah? Come, no problem, yeah? No problemo, bro, yeah? And now you want to take out ey, because obviously that's beta on the top there. You can see they both have 2 ey, so it's obviously begging you to take it out. And now you've got 3 plus 2y, 2 like that, yeah? Alright, so now, listen here. This is obviously dx over dy, okay? You want to find the normal. The normal, the gradient at the normal, yeah, is going to be, the gradient of a normal is going to be negative reciprocal, okay? Negative reciprocal means minus 1 over dy over dx, yeah? When you do 1 over dy over dx or 1 over a fraction, it flips it. So that's going to be minus dx over dy. So what I'm trying to say here basically is I'm trying to say that to find the gradient of the actual tangent here, we have dx over dy here. So you just need to substitute y into here and do negative. You don't actually need to flip this because this is dx over dy. You get it? So it's already been flipped. So you just need to do negative times this and put in the y coordinate and you'll get the gradient of the normal, yeah? If it was going over the tangent, you would have to flip this. You get it? You have to flip this. Alright, cool. So therefore you got that, yeah? So if x is equal to 1 over 3, y is equal to 0, apparently, from the, oh yeah, that's from part A, innit? Alright, cool. Or some shit like that. Yeah, calm. And so now you want to put basically 0 into here, because this is in terms of y, yeah? So you want to find the gradient, so e to the power of 0 to 0 plus 1 over 3 plus 2 times 0 squared, yeah? And that's going to give you 1 over 9. Calm. So therefore m is going to be negative of that, yeah? Because it needs to be negative dx over dy, so it's going to be negative 1 over 9. So that's the gradient there. So now you just need to do y is equal to mx plus c. So y is equal to minus 1 over 9 x plus c. And now obviously put you got their coordinates here, so it's 1 over 3 and 0, yeah? So just put 0 into here and put minus 1 over 9 open bracket 1 over 3 plus c. And now times that together is minus 1 over 27. Bring that to the other side. 1 over 27 is equal to c, yeah? So now you just need to put that into the equation, final equation, and that's all you got, yeah? That's the answer. So minus 1 over 9x plus 27, 1 over 27, yeah? That's the answer. Alright, question 9. Question 9 is saying y is equal to x to the power 4, yeah, over cos 3x here. So therefore, u is going to be equal to the top here. So u is going to be equal to x to the power 4, yeah, and v is going to be equal to cos 3x. And now you want to do du and dv. So du and dv, so du over dx here is going to be 4x cubed, and dv over dx is going to be shit. Bring the 3 outside and obviously, damn, that's crazy. I should clock son. Anyway, yeah, forget about that. Obviously, differentiate cos here, that's going to be sine, yeah? So that's going to be negative 3 sine 3x here. Save. Alright, and now, obviously, the times v times du, yeah? So that's going to be 4x cubed, yeah? Cos 3x. And then take away negative, negative, that's going to be positive, yeah? Because we're using quotient rule here. That's going to be positive 3x to the power 4 sine 3x. All of that over v squared, so that's going to be cos squared 3x. Alright, take out, bro, how are we doing that twice? There's actually, yeah, there we go. See that, yeah? Beat the system. Alright, take out 3 there, x power 3 there, yes, we get 4 cos 3x here, plus 3 x sine 3x. All of that over cos squared 3x. That's the final answer. Alright, question 10a. It's getting bare late. Can't lie. I might have to put it wraps after this exercise. Alright, cool. This is what we're here for, man. This is what we're here for, bro. This is the come up right here, you get me? Yeah, cool, man. Yeah, you're gonna remember these late nights. Alright, du over dx here is gonna be bring the 2 down, and that's e, and that stays the same. And then dv over dx here, bring the 2 down there. That's x minus 2. And then take the differentiate 1 outside, doesn't do anything, doesn't change anything. Alright, calm. Calm. So that times that, that's gonna be 2 e to the power 2x open bracket x minus 2 squared here. And take away that times that, so that's gonna be 2 e to the power 2x open bracket x minus 2. And then obviously here we're gonna have all of that over x minus 2 squared, but we're gonna need to square that again, so it becomes 4, yeah. And now obviously we need to do, the classic, bro, which is to take out the common factor, which is x minus 2. So do that. So take out as well 2ex as well. So 2e to the power 2x here, open bracket x minus 2, and then that's going to open bracket another bracket. Here we just got one x minus 2 left because it was x minus 2 squared and we took out x minus 2, so that's going to be x minus 2. And then here we just got to take away 1, yeah, because we took out the whole thing. So take away 1 over x minus 2 power 4, yeah. And now obviously x minus 2 minus 1 is minus 3, so that's just going to be 2e to the power 2x. X minus 3, and x minus 2 as well. Yeah, over x minus 2 to the power of 4. And again, here you can cancel that and this becomes 3, yeah? Alright, save. V. X equal to 1, yeah? So you define what y is, yeah? So when x equal to 1, y is e squared, yeah? Does it actually give it gives you that, or did I just, create that? No, I just created it. So yeah, apparently if you put 1 into the into the equation, yeah? Into the y equation, it will give you e to the power squared, yeah? Obviously, because 1 minus 2 is just negative 1, yeah? Squared is 1, so it's just e to the power 2 over 1, yeah? So it's just e to the power 2. Come. And put x equals 1 into the dy equation, so that's going to be e squared to find the gradient, 1 minus 3, because it's x minus 3, over x minus 2 squared, so that's 1 minus 2 cubed, I mean. Alright, cool. Put that into there, you get 4e squared, yeah, so that's going to become, yeah, so that's that. Now y equals mx plus c, so I'm assuming we've got a tangent here, so y is equal to mx plus c, so 4e squared x plus c, bro. And now y coordinate is just e squared, x coordinate is just 1. So therefore c is just going to be negative 3e squared here, because take away 4 that side, that's negative whatever here. And so the answer is going to be y is equal to 4e squared here, x minus 3e squared. Alright, question 11 here, 11a. And f of x here is equal to 2x over x plus 5 plus 6x over x squared here plus 7x plus 10. So obviously the second one can be broken up here, so that's going to be 2x over x plus 5, and the second one is going to be plus 6x over, obviously factorize that in your calculator, you'll get x equals minus 2 and x equals minus 5, so that's going to be x plus 2, x plus 5 in the bracket here. Alright, save. Left hand side here needs to be times by x plus 5 on both on the top and bottom to get the same denominator, so that's going to be 2x open bracket, x plus 2, sorry, yeah, not x plus 5 here. And then that's going to become x plus 2, yeah, x plus 5 plus 6x over x plus 2, x plus 5, come. And then obviously now, you just need to combine that, yeah, so 2x times that, yeah, so 2x times x is 2x squared, yeah, 2x times 2 is 4x, and then plus 6x, all of that over x plus 2 times x plus 1. Alright, cool. And that's going to be 2x squared, yeah, plus 10x over x plus 2, x plus 5. And then take out 2x on the top here, so that's 2x there. That's x plus 5 inside the bracket. And that's all of that over x plus 2, x plus 5. And then obviously that. So just left with 2x over x plus 2 here. Alright, save. Alright, part B. So we need to differentiate that now. So u is going to be the top, which is 2x. So v is going to be x plus 2, which is the bottom. Du over dx is going to be 2. dv over dx is going to be 1. Save. And yeah, so find f dash x, that's going to be the differentiated version, so that's going to be v times that, so that's going to be 2 open bracket, glitching bears, but it's going to be 2 open bracket x plus 2 minus that times that, so that's minus 2x over v squared here, so x plus 2 squared here, and that's obviously going to be 2x minus 2x is just 0, and then 2 times 2 is 4, so that's 4 over x plus 2 squared here. I want you to find f dash of 3, so you want to substitute 3 into there, so f dash 3, so just put 3 into there, that's 4 over 3 plus 2 squared here. That's 5 squared, so that's 4 over 5 squared here, which is 25 here. Alright, cool. Alright, final question. Question 12 here. Alright, safe. So f of x here is going to be equal to 2 cos 2x over e to the power 2 minus x. Alright, safe, yeah? The u is going to be 2 cos 2x here. The v is going to be e to the power 2 minus x here. Differentiate that, that's going to be du over dx going to be equal to minus, bring the 2 outside, that's 4 sine 2x here. Find dv, yeah, dv over dx is going to be again, so differentiate that, that's going to be -1 inside, differentiate times outside is going to be negative e, and then the inside is going to stay the same, so we just get that. Alright, save. Now I'll do v times du, so it's going to be that times that, so that's going to be minus 4 e to the power 2 minus x sine 2x. Take away that times that. But obviously you're going to get negative here because negative there, so that's going to become positive here. So positive 2 e to the power 2 minus x here, cos 2x. Order that over e to the power 2 minus x squared here. Alright, cool. And now what you need to do is take out 2 e to the power from 2 minus x here. So 2 e to the power 2 minus x, open bracket. This negative and this thing there, so bring make that again, this is like 2 minus 2 plus 5 here, make it 5 minus 2, you get me? So bring the cos first, so right, cos 2x, because you already took out the 2 to the power 2 e to minus 2 minus x here, and then negative 2 sine 2x here. Of course, we've got 2 left over here because we took 2 already and it was 4 originally here. And then all of that was over e to the power of 2 minus x squared here. Safe. Now I think what we're going to do is just make that equal to 0 because it says f dash x equal to 0, like find stationary point, whatever, or not even, just do some other shit. So make that equal to 0. I don't even need to simplify that. I can. I don't need to. Because I can just times that up there. But I can cancel that there, cancel that there. Just get 2 here. Yeah, you just get 2 there. It doesn't really matter. That's just 2 equals 0 anyway. It doesn't really matter, bro. But what I'm trying to say is times this up here, it becomes 0. So you just get uh and you can divide 2 as well, and it will become 0. So what I'm trying to say basically is just that you get cos 2x here minus 2 sine 2x equal to 0. That's what I'm trying to say. Yeah, because either you can remain the ex there, but you can just times everything. So like you can times this up here, and it's going to cancel. You can divide by e to the power of 2 minus x onto 0, and it will cancel. You can divide by 2, and it will cancel. The only thing that's not going to cancel, they can't divide, is cos 2x and 2 sine 2x here. So you get this situation now. Obviously, when you got this, you need to combine it to make tan, so you need to add this to that side. So that's going to become cos 2x equal to 2 sine x 2x, and then obviously, yeah, man, that's obvious now. Divide by cos there, divide by 2 there, it's going to be 1 over 2. Divide by cos is going to be sine 2x. Or do I even need to write it, bro? It's going to be sine 2x over cos 2x, which is going to be tan 2x here. Alright, so that's going to be tan 2x here. So that's what part A was asking. And now part B, yeah, is going to be to find it, yeah? So make sure things are radian and do 2x. So do tan inverse of 1 over 2. That's going to give you 0.4636, or you need to add pi to that now. Because for tan you need to just keep adding pi here. So add pi to that, it's going to get 3.6. That's going to be the first solution if you do tan inverse of half. And it's going to be 3.6 or 52. Safe. So then divide by 2. So x is going to be 0.2318 or 1.8026 or some shit. Okay, cool. And if you look at the graph here, B is the second thing here. Obviously, this is within a 2 pi range here. I think you can tell from the graph, or it doesn't really matter anyway because it will repeat. It's just taking a section of the graph, so it doesn't really matter, bro. You don't need to keep adding pi here. Just find the first 2 solutions here. So obviously the x coordinate of the of B, x of B here is going to be the second solution, because obviously the first one was the first thing, because that's the turning point or whatever. So you get the first turning point, the second turning point here. So that's the second turning point. So that's going to be 1.8026. The graph doesn't look anything like that, by the way, I'm pretty sure, but you get me. You get the point. Just a little illustration of x. And now, yeah, we're going to find the range. If that's x here, then the range is going to be what? For the range here, I'm going to need to put substitute this whole thing of x into the y. Y was equal to what, bro? I can't even remember. Y was equal to 2 cos 2x over e. So it's going to be 2 cos. So instead of 2x, it's going to be 2 times 1.8026, which is the y equation that gave us in the question, over e to the power of 2 minus 1.8026. Yeah. If you put that in your calculator, it will give you 6. Okay, it's gonna give you minus 1.47, yeah. So therefore, yeah, that's gonna be the smaller number, and now you need to find the other range, yeah, which is the maximum, yeah, which is gonna be at pi. Okay. Because that's where the graph is gonna end, right? So that's gonna be that minimum point there is minus 1.47, where b is, yeah. That's the y coordinate for b, and the maximum point is gonna be at pi, yeah. So therefore, the maximum is gonna be pi. So you need to just do put pi into the equation. So that's gonna be 2 cos 2 pi in the y-axis in the y equation over e to the power 2 minus pi here. That's going to give you 6.26 here. So now the range here is going to be y is between 6.26 and 1.47, yeah, negative 1.47. Alright, cool. That's it.
I started with 0 contacts in my bricky, now it keeps calling me. M-way flying, AMPRs keep haunting me. I just flew 3 corners, B. Only one more left in the key. Chat boss, you don't get like me. No, you don't get like me. Aye, got a man I don't roll with knives. 9 mil fill it up with bang. Okay, lean back then fly. You can get